So this is line 22, 7b97z49b2. My first one, B1, ran out of battery power, so I split it up and made a second video for it, okay? So this is, you want to go back to the first B1 to see where it starts. Dirac, Whittaker Shannon Nyquist Fourier DARPA COUGAR Formula 5G Wow Seti. The first part is just the data, and this is going to have some data and the formula in it in this video. There's the alien radio signal, and I'm working on this one October 5th, and the data was done back in September 13th. So this is a Fourier Transform Whittaker Shannon interpolation formula, sinc creating time band limited function, Nyquist Fourier Transform signals with DARPA COUGAR hollow core fiber optic wires and a formula. Line 22 WOW data B1, B2. This data was divided into two parts. Okay, so the formula and data continues from the previous video, which is almost the exact same title, and the only difference is the B1. Okay, so Google images to show what it means. So quotes, diagrams from Wiki. There's a diagram here. It's got some calculations there on the left there. I'll just make it bigger for a second there. It's kind of blurry. So you can go to Wiki to look at it. Two complex sinusoids, colored gold and cyan, that fit the same set of real and imaginary sample points when sampled at the rate fs indicated by the grid lines. The case shown here is, there's the calculation thingy there. Again, it just goes blurry when I make it bigger, so doesn't always do a good job to make it bigger. If I make it small, you can actually see it better, which is funny, but that's true. Okay, and then here's another diagram with little teeny weeny print that I can't read. Illustrations of 4 waveforms reconstructed from samples taken at 6 different rates. 2 of the waveforms are sufficiently sampled to avoid aliasing at all 6 rates. The other 2 illustrates increasing distortion, aliasing at a lower rate. So the wavelengths of a sine wave can be measured between any 2 points with the same phase, such as between crests or troughs or corresponding zero crossings as shown. Okay. Quotes from Wiki: a sound wave is a variation in air pressure, while in light and other electromagnetic radiation, the strength of the electric and the magnetic field vary. Water waves are variations in the height of a body of water. In a crystal lattice vibration, atomic positions vary. Wavelength is a measure of the distance between repetitions of a shape featured such as peaks, valleys, or zero crossings, not a measure of how far any given particle moves. For example, in sinusoidal waves over deep water, a particle near the water surface moves in a circle of the same diameter as the wave height, unrelated to wavelength. September 14, my thoughts. Looking at the diagrams of the wavelengths, an idea comes to mind. Formula idea. Rubidium atoms, chlorine atoms, tevatron proton energy circle, hollow core fiber optics, and DARPA COUGAR inventions. I'll put a comma there. Spin, leptons, neutrinos, cooled plasma, turbine laser beams, diffraction, obsidian mirrors, collision, graphite films, 2 superlattice walls, crystals, mesh, electron holes. Diffract the laser beam signals at 90-degree angle, mixing with wavelengths to peak the RF frequency signals, and make them go farther in distances. The cooled atoms will use quantum mechanics and transport along the linear lines of blue visible light, diffracting with red visible light to create a crossweave of Higgs boson signals. Bouncing in between the wavelengths, and with Minkowski space-time, it will move upwards in a triangular motion and create a cone of sound that can be amplified by the laser beams from the fluoroscopy, water vapor invention devices. Okay, all keywords shown here. Here are in line 22's WOW signal formulas. So I'm going to cross-reference them all. Cross-reference all lines 1 to 27, which we're going to do at the end anyways. So, an idea comes to mind as I write. Not sure if this would work, but we're going to try it. I want you to try it. I want you to try it and blog your results or theories on what needs to be added to make it work. Okay, so a little project for you guys that want to do stuff like this. Keep in mind Newton's second laws of motion. Add the Hall effect in hyperbole space to these Euclid elements d space. Third dimension physics and Archimedes time travel for atomic pulse equations. I don't know if he's even done that. In his this guy's blog, he's talking about his experiments. So I'm going to Google atomic pulses equations to see what comes up. All sorts of things came up. Add to the end of this section, keyword Nyquist frequency continues in the next video. So I'm just continuing with the PDF file, and then I'm going to get to the atomic pulse equations. There's over 20 videos with it, maybe more, just so you know. There's lots of material with it, so lots of PDF results to look at. So thank you for watching.